So in this video, we're going to start topic 6, considering the concept of inertia and comparing it to mass. So what is inertia? And you should be taking notes on page 21 in your orange packet. So inertia is a tendency to resist changes in motion. It's partly a physical property of a substance, but it is not a force. It's not easily quantifiable. We can't take a measuring device and measure something's inertia. But it basically relates to the concept that things want to keep doing what they're doing. Things that are at rest don't want to move, and moving objects really don't want to stop moving. It's related to mass because the more mass an object has, the harder it is to change its motion. So let's consider trying to move a refrigerator. So the refrigerator has a lot of mass, and it would be really hard for one person to move it across the floor. And that's because the refrigerator has a lot of inertia. It doesn't really want to start moving once it has been resting. On the other hand, once it is moving, it doesn't really want to stop easily because it has that tendency to want to keep doing what it's doing. If you think about a book is relatively easy to get it to slide across the table. So even when it starts at rest, it's pretty easy to give it a push, a fairly small push, and it will start moving. So a book doesn't have a whole lot of inertia compared to a refrigerator. So the larger the mass, the larger the inertia. So let's talk a little bit more about inertia before we continue taking notes. So we're going to skip to orange page 22, and then we'll come back later on to take notes. So on orange page 22, we have a worksheet from Physics Classroom, and this one starts out with writing what inertia is. So inertia, again, is the tendency of an object to resist any changes to its state of motion. So number 2, the amount of inertia possessed by an object is dependent solely upon its mass. So number 3, we've got to visualize this idea that they're giving us this scenario for. So 2 bricks are resting on the edge of a table. Shirley Sheshort stands on her toes and spots the 2 bricks. She acquires an intense desire to know which of the 2 bricks is the most massive. Since she's vertically challenged, she's unable to reach high enough and lift the bricks. But she can reach high enough to give the bricks a push. So discuss the process of pushing the bricks and how that will allow Shirley to determine which of the 2 bricks is more massive. What differences will Shirley observe, and how can this observation lead to the necessary conclusion? So again, let's think you're trying to reach on top of a shelf that you can't fully pick things up off of the shelf, and you're trying to push them on top of the shelf. Well, the one that resists moving more is going to have more mass, and it has more inertia. The one that resists moving less has less mass and has less inertia. So you'll be able to feel the resistance to that trying to get the object to move. So you'll feel the resistance in that due to the inertia. So I hope that makes sense. Number 4, would Shirley Sheshort be able to conduct the same study if she was on a spaceship in a location in space far from the influence of significant gravitational forces? Well, the answer is yes, because all objects have mass, even if they're out in the middle of space, and they all exhibit the same degree of inertia as they did on Earth. Their weight is due to gravity and how close they are to Earth, but that doesn't have anything to do with this whole tendency to resist motion. So this is a concept that you need to kind of wrap your head around and think about the fact that mass and weight are not the same thing. And this idea of inertia being tied to weight is not really accurate. Inertia is tied to mass, or how much material there is in an object. So number 5, if a moose were chasing you through the woods, its enormous mass would be very threatening. But if you zigzagged, then its great mass would be to your advantage. Explain why. So the large mass object, the moose, has a lot of difficulty changing its state of motion. And this is due to its inertia. So by zigzagging, you have less inertia than the moose. So you can zigzag a little bit easier than the moose could. So this will help you evade being hopefully caught by the moose. So the moose will tend to go straight because it is much harder for him to zigzag. Number 6, inertia can best be described as the force that keeps moving objects moving and stationary objects at rest. No, it's not really a force. B, the willingness of an object to eventually lose its motion. Well, no, it's not just losing motion, it's its tendency to maintain its motion. C, the force that causes all objects to stop. No, it's still not a force. And D, the tendency of an object to resist change and keep doing whatever it's doing. Yes, D. So number 7, mass and velocity values for a variety of objects are listed below. Rank the objects from smallest to greatest inertia. So remember, inertia only has to do with mass. It doesn't have anything to do with velocity. So for this, we just want to compare the masses. So the one that has the smallest mass is going to have the smallest inertia. And if we look at these, that would be object C. Then the next smallest would be D. The next one would be A. And the one with the most inertia would be B. So if you want to see the formal answer sheet, so you can pause the video here. So this has 1 through 4, and then here is 5 through 7. So for some additional practice, you're going to work on page 23, which has similar but slightly different questions talking about mass and inertia. And once you finish that, be sure to upload your answers to Google Classroom. And in the next video, I'll go over the answers.